It's always in reference to the angle they're talking about. So always in reference to the angle they're talking about, opposite, adjacent, hypotenuse. And then, of course, you know your SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And so if you wanted the 6 values, you would just give those, and you want to make sure you reduce. So don't put them as a decimal, don't put them as a mixed number, but you do want to reduce your fractions. All right? In the next type of problem, find the value of x. So in this case, again, they gave you an angle, and you want to label this triangle, the sides that they have given you, with the, in reference to that angle. So if I'm looking at this one, which trig function am I going to use for finding x? Yeah, so I should say the sine of 27 degrees equals opposite over hypotenuse. And so you would just then do what to solve? Yeah, just multiply. We're going to multiply both sides by 11. And so rounded to the nearest tenth, you would get 5.0 there. 5.0. And then the last thing we did in this section was we found angle measurements. And when you're finding angle measurements, what do you do? Which function do you use? Which type of function do you use when you're finding the angle itself? Inverse, right? And so once again, like we've done for every other one of these, we are going to label this triangle based on the angle that we have, opposite, hypotenuse. And so once again, we would use sine here. Sine of theta equals opposite over hypotenuse. But in this case, we're solving for theta. So we're going to say sine of -1, or inverse of opposite over hypotenuse, will equal your angle. And for this one, you should get about 20 degrees when you round to the nearest degree. Section 2 was degrees to radians and radians to degrees. The biggest problem I'm seeing is reducing incorrectly. So if it's degrees, we're going to multiply by what? Pi over 180. And if it's radians to get to degrees, we're going to multiply by 180 over pi. All right. And so when you do these, you want to make sure that you reduce correctly. You're not going to give me decimals here or anything like that. 135 times pi over 180, and you want to reduce that guy out and leave it as a fraction, which would give you 3 pi over 4. All right. For the 2 pi over 3, you want to do the same thing, 2 pi over 3, 180 over pi, and you want to cross cancel and reduce there as well to get 120. And just pay attention to your reducing. We did 2 types of problems here. We did arc length and area of the sector. What is my arc length? Arc length, what is that formula? R times
theta.
Theta, and specifically theta has to be in radians, right? And then sector, this is 1/2. Radius squared times your theta. For area of a sector, then I'm going to say 1/2 my radius squared times, I need this in radians. So instead of 31, I'm going to say pi over 180. Right. 53.0 square inches for this one. Just find the exact values of the 5 remaining trig functions. This looks very much like right angle trigonometry. But the difference here is it gives you more stipulations. So here it said the cosine is 2/5, and without saying it, the cosine is positive, right? And then it tells us that the sine is positive, all right? Sine is positive, and it tells you that the tangent is positive, right? And so you're going to figure out what quadrant you're in based on the information it gave you. So if your cosine and your sine are both positive, what quadrant are you in? The first quadrant. And so then you're going to do it just like right angle trigonometry. They gave you cosine, so they gave you x over r, basically, right? X over r. You're going to solve for your y, and then you're going to do your trig functions based on where you are. They're all going to be positive. So you're going to use Pythagorean Theorem to solve for y. X squared plus y squared equals r squared. And then you're going to use that y to do the remaining trig functions that they gave you. And these will all be positive. If you had been in a different quadrant, you would have some negatives thrown in there. All right, so this is what you would have done on bell work. Your question will look much like this: amplitude, period, frequency, phase shift, vertical shift of each function. And so you have to keep in mind the standard form, A, cosine of B plus C, and then we have a plus D over here. And that's where all of these questions are going to come from. So which one is your amplitude? What is your amplitude represented by?
1/2 A.
Yeah, absolute value of A. In this case, it would be 1/2, right? What about then your period? How do you do period? What's your formula for period? 2 pi over B, technically absolute value, right? And so in this case, my B is just 1. So my period here is 2 pi, right? What about frequency?
1 over period.
Yeah, just flip your period, right? So your frequency is just going to be 1 over your period pretty much, which is in this case 1 over 2 pi. All right. What about phase shift?
C over or negative C over the absolute value.
Negative C over absolute value of B. C is pi over 2, so negative pi over 2 over B is just 1. So negative pi over 2 is your phase shift. And then vertical shift. What is vertical shift?
Yeah.
Vertical shift is D, and in this case, we don't have a vertical shift. Yeah. There is no vertical shift. And so for a cosine graph, we typically start at 0 and end at 2 pi, right? Start at 0 and end at 2 pi. We now have a phase shift of negative pi over 2. Negative pi over 2. So now I'm going to start at negative pi over 2, and I add my period basically to it. So if I start at negative pi over 2, where will I end? Where will I end? Normally I would end at 2 pi. I need to add 2 pi to negative pi over 2. Yeah, 3 pi over 2. Just a pi over 2 away from 2. So basically I took the whole thing and shifted it pi over 2. And so I need to divide this guy in how many segments? 4, right? Make sense? All right, so I'm going to divide it 1/4, 1/2, 3/4, right? 1/4, 1/2, 3/4. It is a positive A, so I'm going to graph it up and down the way I normally would. Where does your cosine graph start? It starts at your highest point typically. My amplitude is no longer 1. What is my amplitude? 1/2. So now this one, if this is my 1/2, negative 1/2. I don't have a vertical shift. If I did, I would shift that first before deciding where I'm starting, but I don't. So I'm going to start at 1/2. At 1/4 of the way through, where is my cosine graph? At my, what's it called? What's that point in the middle? The midline, right? At halfway through, where is my cosine graph? My lowest, right? 3/4, it's back at my midline and ends at my highest point. All right, and so then I'm just going to sketch that. All right. So in section 6, we talked about inverse trig functions. Inverse trig functions just basically are solving back using unit circle. So it says the inverse sine of -1. You're going to use your unit circle and say, what gives me a sine value of -1? So what gives you a sine value of -1? Sine value of -1? 270. And And so keep in mind too that when you're doing inverse trig functions, your what's your domain actually that it's talking about for as far as your input and your range, remember? So for sine, remember we use just these two quadrants, right? So for sine, we're actually going to use from negative pi over 2 to pi over 2. So if I were answering this question considering that, I would not say 270. I would say what? I would say negative pi over 2, right? Does that make sense? Doing these, you've got to consider that you have to do the range and domain that it's given you for that particular function, all right? Tangent actually has the same exact thing, right? Tangent has the same area. If it had been cosine, we would have used the first two quadrants. So what gives you a negative square root of 3 over 3? A negative square root of 3 over 3. Works. So negative pi over 6, right? That's going to just be pi over 6 in the fourth quadrant. You end up with a cosine of what? Square root of 3 over 2. And a sine of negative 1/2, right? We're looking for tangent. So tangent is sine over cosine. Right? Keep, change, flip. Change to multiplication, flip. You end up with negative 1 over square root of 3. You don't leave it like that. Square root of 3. Square root of 3 gives you the negative square root of 3 over 3. All right? So tangent's harder than sine or cosine, for sure. All right, so law of sines is the more simple one, right? Law of sines is going to tell you sine of A over A equals sine of B over B, which equals sine of C over C, right? That's the easier one. Law of cosines is C squared equals B squared. Well, we'll go A squared, not A squared plus B squared minus 2AB cosine of C. All right? And so when they want you to solve a triangle, they are wanting you to solve for all three sides and all three angles. All right? All three sides and all three angles. They gave you 3 sides, so you have to start with law of cosines. If you have no angle, you have to start with law of cosines. The only way you can start with law of sines is if you have an angle and the side opposite. All right? And so they're wanting you to use law. So I would start with law of cosines. Once I had one angle, I would move to law of sines. And then once I had 2 angles, I would know that my angle measures equal 180. And I would just subtract from 180 to get my third. Okay? So start with law of cosines, move to law of sines, and then just do what you know about the degrees in a triangle at that point. So always use path of least resistance for these. So you will have a word problem using one of the methods, at least one of the methods you've used, if not a couple. Painter's using a 15-foot ladder to paint. If the angle the ladder makes with the ground is less than 65 degrees, it will slide off from underneath him. What's the greatest distance that the bottom of the ladder can be from the side of the house and still be safe for a painter? And so you will not get a picture from me. I won't give you a picture, so you have to sketch your own, right, and set it up.